Another video for the series, and today I decided to solve an IMO problem from 1995, IMO problem number 2. Now that I think about it, if I actually had spent time on this problem, I might have not entirely solve it, but solve it until I get 2 points or 1 to 2 points. I was quite scared that it was number 2, and I just looked at the solution, but I think this is the solution I'm providing, giving you in this video is by Aritina 12 in AOPS. I'm not sure who he or she is, but I really love the solution. There are lots of solutions for this one, but I found this typically really concise, but also really brilliant. So this is how it goes. So first, what they did is, what he or she did is, or what we can do is mirror this. So what I mean by mirroring is let A equals 1 over x. Something's wrong with my pen, I think. And B equals 1 over y. And Z equals, and C equals. Can you see this? Okay. Now we know that 1 over x y z, a b c equals 1 over x y z equals 1. Therefore x y z equals 1. Now let's try and use this in here. So we have x cubed all over b plus c is 1 over y plus 1 over z, which is y plus z over yz. And then similarly we can do the same thing. I think we can calculate it quickly from here because we know that this thing is cyclic, plus z cubed over we did yz, zx, we did into xy. Now, so this is the left hand side right now. Notice that because xyz equals 1, we can change it like this. Y plus z, y squared, x plus, I will say z plus x for convenience, plus z squared over x plus y. Now we just need to prove that this thing is greater than or equal to 3 over 2. Now I think so there are few things that we can consider from here. I think many of the other solution continued from here. So I think finding this one was really important. I couldn't do it, but and then I found this thing, this part really interesting, but we can actually use Tito's lemma here. And the reason why I quite doubted Tito's lemma is because Tito's lemma is, I mean, it is a famous lemma, and it is from one of my favorite mathematician, Tito Andrescu. So I really love the lemma, but it's not like official inequality. But anyhow, this is how it goes. So I forgot a sub 1 square. Yes, I think this should be right. I'm sorry, I need to review more on the inequalities. I think this is right. But anyways, I'm going to prove it here again, so if I get it wrong, I think it was b sub 1 plus b sub 2 plus, and we have a sub 1 everything squared. So this is a proof. Like actually the Tito's lemma is direct consequence of Cauchy-Schwarz inequality. And if I remember correctly, the way to prove it was assume first assume that yes, I now remember. So it was so this I'm serious, this is how it goes. So first, before I do that, I will quickly introduce the Cauchy-Schwarz inequality. I will use x and y here because we need to use x and y here. Y sub n squared is greater than or equal to x2 y2 plus dot 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 plus x sub n y sub n squared, right? So this is a trick right here that one of my favorite mathematicians used. So notice that when we multiply our denominator to here, I mean this thing is quite off topic, but I wanted to like share, and I need to prove if my memory is correct. So I think so. Let x sub I equals root b sub I, and that is totally fine because we know that a and b are positive numbers here, meaning x, y, z are positive numbers, and thus a sub I, b sub I are positive numbers. Y sub I equals a sub I over root b sub I. I think this is how they did. And then when we substitute it, we get b sub 1 plus b sub 2 plus dot 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 plus b sub n. And here we have a sub 1. Yes, this is right. B sub 2 plus b sub n. And obviously, this part should be a sub 1 plus a sub 2 plus dot 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 plus a sub n squared. And when we divide this, we get our Tito's lemma. So I'll just write it. And we proved it. Now we will somehow use this thing to here. And I think that was quite brilliant. So first, we know that x squared plus, so this is, I will just what am I saying? I will just rewrite what we need to prove. Y squared plus x plus y, or z squared is greater than or equal to. So this is what we need to prove. This is our lemma. Now let's use our Tito's lemma here. So notice that these are in the same form, so we know that this thing, our left hand side, or I will just write it. I don't think it will take that long. This thing is greater than or equal to 2 times, or we can, when we add our denominators, we get 2 times x plus y plus z. And we have our sum of our a sub 1 plus a sub 2 plus a sub 3. This is x plus y plus z squared. Now notice that this is greater than, this is just simply equal to x plus y plus z over 2. Now let's use our lovely AMGM inequality here. It just comes out everywhere. This is obviously greater than or equal to 3 times cube roots of x, y, z. But notice that this is equal to 1, so this is equal to 3. So because we know that x plus y plus z is greater than or equal to 3, we know that, why am I keep writing that? Over y plus z plus y squared over z plus x plus z squared over x plus y is greater than or equal to this thing right here. But this thing, I'll just write it. But this thing is greater than or equal to 3 over 2. and thus our lemma is true. And because this is just the same thing as our inequality right here, we proved our inequality. So I really loved the problem, and I really loved the solution. So that's why I really wanted to share it with everyone. So I think the first kick that I couldn't think of was trying to mirror our inequality here, and then use T2's lemma here because we have square, 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 and not squares in here. So I think that was really brilliant. And I think compared to other IMO problem number 2s, this is comparably easier than other ones, but I mean it's from year 1995, and I don't think it is right to compare with the later IMOs as it gets harder. But I really loved I mean I couldn't solve this problem, so yeah. But I really loved the problem. I really enjoyed the solution, and thank you so much for watching this video. If you also like this solution, please feel free to share and like the video. Thank you, and see you tomorrow. Bye.